In this example, or this idea, we're going to be talking about inverse relationship between differentiation and integration, which is this idea that if we were to do the antiderivative of something, then that's going to give us the original function, but then turn around and do the derivative of that function. Basically means it's just going to get you right back to where it begins, except it depends on what you have that you're plugging in. And the way this always looks is that you have some value that you're starting with, and you're going to have an unknown attached to this. So something like this, you're going to go from a 2 to an x or a 1 to an x squared. And so when you have that look, they really just kind of undo each other, except when you have something other than an x on there, you're going to need to take this, but then it's going to be multiplied by the derivative of that piece. Okay, that's the one little hitch to it. So there's a shortcut to it. The long way would have been we take our equation, we do the antiderivative of it, we plug in the x, we plug in the 2, we do the math, and then we do the derivative of it all back over. You're going to find that it's really just going to turn into the same thing as if we just sub that out and just put 2x plus 5. Right? Unless you have something that is a little bit more of a complicated value that you're plugging in. So if you have a little bit of a more complicated situation, then you're going to not only, you're just going to plug that in, which is what we did here. So you are going to take x squared and replace it into the t and still square it. So you're going to clean that up a little bit. But then it's also going to be multiplied by that derivative of it. Right? That's kind of the short version of this. So, so that is literally my answer to this. So you're going from that a value to x. It basically undoes itself. Go ahead and sub that value into your function and then multiply it by the derivative. So the derivative of x is 1, so it doesn't change anything on this particular problem. So if we do the next one, same exact thing, but the problem is it's not written correctly. So I need to rewrite it and switch the order on this. And so if I switch the order on this, that changes it to a negative. That's my space here. That negates the problem, basically. So t squared plus 1, and then derivative with respect to t. Okay, so now it's in the right form. The derivative of x is not going to add anything to it, so all I have to do is just sub it in. And that negative is still there. I just replace the t with an x. So then my answer would be x squared plus 1, and that's it. All right, on this one, we do have this derivative of a 2x that we're going to have to tack onto it, and we're going to have to sub in an x squared. And so we're looking at, there's nothing special. We go from a number to a, so the order is fine, where we didn't have to switch it like this one. And so we're going to take x squared, but then it's going to be squared. And then you're going to also, so x squared, and then it's going to be squared, and then you're going to multiply it by the derivative of that piece. So 2x. So this is us saving some time, basically, that there's a pattern going on. And like I said, we could do the antiderivative of this, get an answer, plug in the 1, subtract, plug in the x squared, subtract the 1, simplify that, and then do the derivative of it. But it's going to end up turning into 2x cosine x to the 4th. Right, there's a pattern. There's a little bit of a shortcut to it. Right, and then we do the last one. We're going to be plugging that in. The derivative of cosine is a negative sign. So we're going to first sub in. We're going to have a cosine x. And that piece is going to be raised to the 4th plus 6. And then that's going to be multiplied. So that was the first part is our order is okay. It doesn't matter where we start. We're going to some sort of a variable. We just sub it in, which we did. And then we're going to be multiplying it by the derivative of that, which is negative sine x. So if we simplify that a little bit, not a whole lot we can do. I'll just maybe pull the sign in front. And then it's times cosine, not cosine squared, but cosine of the 4th plus 6. And if you wanted to distribute, you could, but not really changing much for your answer. All right, so that was doing the antiderivative and then the derivative of a function and kind of seeing what you get out of that.